This is a Q.
And the R is 0.
Yeah.
Independently.
Mentioned, by the way, if it was in 3 dimensions, so to be conservative, you do the curve to be 0. Okay, that we have done, I guess, in the previous lesson.
Yeah. So just so
You can still apply the curve,
line.
but we have another way to figure out if it is conservative. If you derive p with respect to y, should be the q with respect to x. So this is like deriving p with respect to y. This is deriving q with respect to x. Okay.
It's like exact equations, basically.
Sorry.
Like if they're exact, so this looks like exact equations now.
Yeah, they should be equal. They should be equal to be conservative, right? If they are not equal, it's not conservative, so potential function doesn't exist in that case.
Yeah.
Okay, now deriving this with respect to y, so be careful. You have a y as a product of e power y. So this is product rule. Okay, product rule. So u prime v plus v prime u, deriving with respect to y for that part is a -1. Okay, to the power, is it? Okay, plus deriving this e is the same. Deriving the top with respect to y, you get minus x multiplied by minus y. That's it. Okay, let's keep it. If we need to simplify, we'll do. But let us figure out qx now. Can you do qx?
So it's
In
same thing. So
so
minus
this
one.
is q. Okay, so this is
Minus one. Either
again -1.
minus.
So this is similar. -1. They should be same, by the way, but let us figure out. Okay, derive
Minus x and
x, so minus y pops. So it's like minus y then minus x. Now, because commutative for multiplication, so they are equal. It means now in the question they don't ask in the book like to go on finding potential, but I would do so. Okay, so let's do the potential function. Find phi. Phi is your potential function. Okay, go ahead. Find your potential function. Okay, how do you start? Again, let me copy what is good. Okay, so again, this is your P, that is your Q. Okay, capital P or capital Q, no worry. So you say your function y is your potential function. Okay, we call it. Okay, and it would be integral of the P with respect to x first. If you integrate minus y e power with respect to x, so you consider y in this case as a constant. So that has no role. Even you can take it out of your integral, okay? Integrating e power something with respect to x, so this is your constant with a minus y. So the minus y would stay, the e stays, because integral of the e is the same. You divide by its derivative, which is minus x. Or minus y, it should be minus y. Because you are integrating with respect to x, minus y is your constant. Any question? Okay, now what do you get? You get a constant. We said it's a function in y. Okay, and if you simplify, you get back. So this is my, let's say, potential function symbol. So it would be e power minus xy plus g of y. Is it okay? Now, if you're pausing for the integral, let me put it in note. When you integrate e power, let's say 3x, what do you get? You get 1/3 e power 3. Why? Because when you derive, you get the 3 to the front, so it cancels. It makes sense? When you integrate, divide by its derivative of the top. So in this case, e power xy dx, if I am integrating with respect to x, my y is considered like a 3, like a constant. So it would be 1 over y, e power x. For that reason, I put it here because there's a minus. Is it good? Okay. Now, what comes next? You derive potential function with respect to y. So I can write it this way. Okay, it should be q. It should be q. If you derive this with respect to y, you get minus x e power, because again, this is considered to be your constant beside y, plus g prime. The q is, again, Okay, so they cancel. So those cancel. You get g prime y to be 0. You
It's a constant.
expect to get it a constant. So it's a c. Anyhow, so this is your potential function. Your potential function is simply your e power minus xy. Okay, you can put plus constant. Okay, perfect.
Yeah.
Yeah. Similarly for the rest. Now, if you wanna evaluate from a point to another, what to do is you plug your points at the end. Okay. If you wanna
Okay.
find, for example, this is the application.
Yeah.
So if you wanna find integral of FDR over a certain path, what I am doing is like I'm applying all skills on one problem. So I want
Problem, yeah.
extra question. Extra now. Okay, let's say you want to find the line integral of the R. So this is exactly by theory. This is the work done, by the way, and it would be your potential function automatically. Okay.
Yeah.
Now, because it's independent of the path, conservative being independent of path. So if I ask you to integrate this over a path, let's say C, and I would define it. So let's say from point to point or whatever. I mean, the easy question would be from point to point. Okay, but when the C path is, this is what we want to see in coming lessons. When the C path becomes harder, like a circle, later a sphere or something or whatever.
Yeah. That's what we were doing last class. We started looking at points.
Yeah, so it would be to apply different, let's say, theorems like a Green's theorem or Stokes theorem and so on. But now it is from point to point over a C, let's say, to B. If A, for example, let's say let's say 1 minus 1 to B, let's say 1 or minus 1, 1, okay. Okay, this is extra. So all you have to do just to plug all this in. So you say integral of FDR over the line integral C path would be over evaluated from A to B. It means you put A first, B next. If it is, by the way, B to A, it would be different. So be careful. B here, A there. It matters. Now B put first and then A. So it is phi evaluated over the point B minus phi over point A. So anyhow, it was E. You same answer. I can make this a different number too. Just not to have a 0. Okay. So phi over point B minus 2. E to the power minus 2 minus, you put this in, you have a minus with a minus, you get a plus. Is it okay? And it's a minus minus, you get a plus 1. By the way, here we have a minus 2, you get plus 2. Why minus plus 2? So it's E squared minus E. Is it okay?
Yeah, makes sense.
Because xy is a negative 2, with minus, you get a positive.